Hi, everyone. Welcome. This is Matt Keep. Welcome to the MongoDB podcast. Really excited to be with you today to talk to you about some new content that we have, which is called MongoDB Evolved. If you're running an older version of MongoDB or perhaps looked at MongoDB a few years ago and decided perhaps it wasn't quite the right database fit for you, we have some new content that can take you through the journey of MongoDB from being a fairly niche NoSQL database 10 years ago into now the database that's been consistently voted the most wanted by developers on Stack Overflow for the past few years.
Welcome to the show. On today's episode, Nick and I are chatting with Matt Keep, who is a part of our product marketing organization. Matt has amazing database industry experience and shares details of a white paper that he's helped put together, which chronicles the evolution of MongoDB since the first release back in August of 2009. So many advancements in all of the areas of data integrity, resilience, performance, scalability, versatility of the query API and the drivers, as well as security and privacy, last but not least, of course. It's a wonderful discussion about all of these things. Keep in mind, this discussion was recorded approximately a month ago from the time we're going to publish it, and we talk about MongoDB.live being next month. It's actually this month. It's July 13th and 14th of 2021. You can head on over to MongoDB.com/live to register, find out what's in store. Hope to see you there, of course. I hope you enjoyed this episode.
You're listening to the MongoDB podcast. MongoDB podcast? Exploring the world of software development, data, and all things MongoDB. And now your hosts, Michael Lynn and Nick Raboy.
Matt, welcome to the podcast. It's great to have you on the show.
Great to be here. Thanks, Mike. Thanks, Nick. I know you've run over a year of these podcasts, got a great audience, and I'm glad to see my efforts of wearing you down and letting me come on have finally paid off.
Matt, I'm wondering if you would tell the audience who you are, what you do, and how long have you been at MongoDB?
Sure. So my name is Matt. I'm based out in the UK. I run product marketing for the MongoDB database and drivers. Now, I know when people mention the term marketing in front of developers, they naturally recoil. While we're called product marketing, we're not actually part of the marketing organization at all. We're part of the product team. So we work very closely with our product management colleagues. And our goal really is to work with our users, our customers, to make sure that we're building the products and the capabilities and the features that they want and need to use as they're building new applications, but also to go out to those parts of those developer communities, for example, that we're not currently serving and figure out what it is we need to build to make their lives better. And then we'll take that back into engineering. Engineering will build these great products and features. And then, again, our responsibility is to take those features out, to communicate them to the marketplace, to ensure that really developers can understand the sorts of things that they can do with MongoDB, the capabilities that we deliver. So that, in a nutshell, is what the product group and product marketing does at MongoDB. In terms of how long I've been here, I'm approaching my 8-year anniversary. I joined in July 2013. So I'm an old timer in two senses of the word. One in terms of MongoDB years, and one in terms of actual human years, because I'm no spring chicken. So I've been around for a little while around databases for a time. I've worked with Oracle and MySQL and around that technology for a number of years.
Mike, that's longer than you, right?
Well, yeah. So I started in 2015. So yeah, he's got a number of years on me for sure. At least at MongoDB, I think we're probably somewhere around the same age. But so tell me a little bit about what happened prior to coming to MongoDB. I know that you were in the database space for quite some time. Do you want to talk a little bit about your previous history?
Sure. I mean, I started out my career, I don't want to go too far back because it goes back many, many years, but I started out as an analyst programmer. And, programming was something that I could do, but I never particularly enjoyed it and wasn't particularly good at it. What would take some of my colleagues like 100 lines of code and an hour to write would take me all day, and 500 lines of code and lots of cigarettes because I was smoking at that particular time. Thankfully, I've knocked that on the head. But my strength really was more around the kind of systems analyst side, which I think is more something we would call an architect these days. So it was really about working with the business to understand their requirements and then turning that into a set of functional specifications that our engineering teams, our development teams could use and build from. And I worked out in industry. I worked in the oil industry actually for a number of years in an analyst programmer role, and then moved across into the vendor side of the world, working in pre-sales, working in consulting, before heading into product management and product marketing, which is where I've been over the past kind of 15 years of my career, mainly working around databases over that time. So I was at Sun Microsystems, and 60% of everything that they sold, their Spark and Solaris, was all running kind of Oracle databases. So I worked very closely on that relationship. And as I mentioned earlier, I worked in MySQL for a number of years, both pre its acquisition by Oracle and then in Oracle itself, before heading over to MongoDB in 2013.
So to set the tone for some of the stuff that we're going to be talking about, so you're pretty proficient in MongoDB as well as relational databases, then, correct?
Yes, yeah. I mean, I've worked on both sides of on both of those kind of technology divides, if you like. Yeah.
So how was that coming from the relational world and beginning to wrap your head around document-oriented databases versus the relational model?
There's some stuff you have to unlearn along the way, but there's also a lot that's pretty common. So in terms of, unlearn with a relational database, and let me say, I'm not going to dump on relational databases. A phenomenal technology, great fit for many, many use cases. But what we see is that as kind of working practices change, as companies move towards more sort of agile development, which they've been trying to do for a number of years, toward DevOps, towards continuous integration, continuous delivery, re-architecting from monoliths to microservices, deploying into the cloud onto elastically scalable distributed infrastructure. Of course, you can do those things with relational databases, but it just takes a lot more time, effort, and typically money to do it. Whereas a distributed database like MongoDB, based on the concept of documents, a lot of that stuff becomes much faster, a lot more natural. And so really, with a lot of the experience I had around relational databases, they were running a lot of kind of existing workloads and doing that really well. But as companies were looking to get into, more modern methods of development, it just became a much, much tougher fit. So coming into MongoDB, you had to figure out, well, why is this document thing? We don't normalize data, and we don't have joins, and we don't have some of those things that you would take for granted. And you'd figure out pretty quickly that actually you didn't need a lot of those things, because your data modeling is so different. Rather than normalizing your data across lots of parent-child tables and enforcing transactional guarantees across those things and joining them together when you were querying it, a lot of those things went away in a technology like MongoDB or other document databases, because documents are these very rich data structures where you can embed and collapse a lot of those previously separate normalized tables into a single rich document. So in many cases, it eliminates the requirement to join. It eliminates the requirement to have multi-record transactions, though those are two things that we've added to MongoDB to serve a broader range of use cases. So you were kind of unlearning some of the best practices that have been established, but there were also many things that were common. When you look at some kind of more modern so-called NoSQL databases, and MongoDB does fall into this NoSQL realm, though it's a term that we particularly don't like. We don't think it's a particularly valuable term. You had a lot of these databases which gave you much more flexibility in your schema, so you could adapt your data model at any time as you were adding new features to your application. They gave you a lot of scalability, a lot of resilience, because they were built on distributed systems architectures. But at the same time, they threw away a lot of the things that made relational databases really useful, things like strong consistency, strong integration with security and management tooling. They threw away, a very rich query API, or, like a query language. You could only really do fairly simple key value lookups, and you have very limited indexing. Those are all things that were maintained in MongoDB. And so, when we think about, one of the toughest performance challenges, I know you've had a number of people on the podcast in the past talking about performance, still the number one issue if users are getting poor performance from a database, any class of databases, is because they don't have the right indexes. Well, guess what? Exactly the same thing applies in MongoDB. So there's a lot of skills for those people who are coming from a relational background that are preserved as they look at more modern alternatives like MongoDB, as well as the requirement to look at how you'd model your data in slightly different ways from perhaps things they've been used to previously.
Let's just touch back on a few things that you said. So first of all, you said that you don't particularly like the term NoSQL. What do we prefer? Do we prefer like non-relational, or is there another kind of category that you would prefer people to start using?
I mean, non-relational is used a little bit. I think it's always challenging to define yourself by what you're not, right? Like NoSQL or non-relational. I think just distributed database it pretty much encapsulates a lot of what we do, and that there's no real standard way for this term. And I also think the term, everything is just a database at the end of the day. In the past, you had clear divisions between relational databases and NoSQL databases, but we are seeing more convergence between those technologies. We've seen relational databases add, for example, support for JSON documents over the past couple of releases, really on the back of the success and the adoption that MongoDB has had. But there are also features we've taken from the relational world. And so I think those barriers between these terms of relational and NoSQL ultimately go away. They are database management systems at the end of the day. And I think those divisions become increasingly artificial and irrelevant.
Makes sense. One of the things that I really enjoyed as I started to learn about MongoDB when I came on board was looking at the evolution of the changes that have been made to MongoDB. And, I still, an iteration of this slide still exists today that walks through all of the things that have been added to the database version over version, year over year. And I think you were responsible for one of the early and even to this day iterations of this slide. I wonder if you can talk a little bit about putting that together and maybe talk about the evolution of MongoDB. I think we're gonna focus in on a white paper that you've recently put together that kind of coalesces or pulls together all of that that data around the evolution of MongoDB. You want to talk a little bit about that white paper?
Sure. The genesis of it came from a number of meetings and discussions that I was having, either with MongoDB customers or those in the community, or even developers generally. There were some who were running perhaps older releases of MongoDB and were figuring out whether they should really upgrade to newer releases. Now we know upgrades of your database can be pretty quick, especially if you're using something like MongoDB Atlas, which is a fully managed cloud service, because you click a button or make an API call and the database is upgraded for you. But that's not the story, right? The story is you've got to upgrade your application. You typically got to look at your application as well, because something may have changed in the database, which means that now it reads and writes data in a different way. And this is true of any database, right? So upgrades are non-trivial. There's a lot of certification and application testing you have to do. And so, we have people who are running older releases saying, well, why should I upgrade to the newer version? What am I going to get out of it? Similarly, we had people who had perhaps looked at MongoDB 10 years ago and who at the time felt MongoDB wasn't the right technology for them. It was a very young technology at that time. It was pretty immature in certain areas, and they felt, it's not right for us. But now they're seeing other users, perhaps peers in their industry or other departments in their company, who are using MongoDB in big ways. And again, they're trying to figure out what's changed. Now, the only option that those people had was to look through potentially hundreds of pages of release notes to figure out what was different. And so I thought, well, how can we make that a lot easier? And so that was really the genesis for the idea of this new paper, which is called MongoDB Evolved. And what it does is it really tracks the major developments in MongoDB since kind of like 10 years ago, a little less than 10 years ago, through to the present day. And it does that through four lenses, four things that people really care about. So one is around resilience and data integrity. Another is around performance and scalability. A third is around the whole versatility of the query API, so what you can do with the database, what sort of queries you can run. And the fourth was specifically around security and privacy. And so theming the features and enhancements in those lenses, it makes it very easy for people who are interested in learning what's changed in MongoDB to download this paper. It's like just over 10 pages. They can skim read it, very quickly jump to those areas that are specifically of interest to them and get, a really quick view of what has changed in the database over the years, because there's a lot that's evolved, hence the name of the white paper, in the technology over the past decade that can help, I think, hopefully make people make a more informed choice whether they should upgrade or whether they should take another look at MongoDB to see what has changed since they perhaps looked at it 10 years ago. So that was really the genesis for this effort. And yes, going back to your original question about the slide, I did create it. I still maintain it. It's getting longer and longer in terms of what we've added to the database over the past few years. But you'll see it at MongoDB Live when we host that in a few months' time.
Yeah, do you want to talk a little bit more about MongoDB Live since we're on that subject?
Sure. So MongoDB Live runs in the middle of July. It's our annual developer conference. It's typically the time where we, bring many members of the community together so we can share best practices, both from MongoDB engineers and MongoDB consultants, as well as people out in the community who have built really interesting projects and applications around MongoDB. And it's a great opportunity to come along and learn all of those kind of best practices. Of how to get the most out of the technology and see the use cases it's serving. And it's also typically the time of year when we talk a little bit more about our vision and about new products and features that we're introducing. And so, we plan to provide much more detail around our next major release of MongoDB, which will be MongoDB 5.0, which is coming around that timeframe. So we'll be giving a lot more information on what's in that new release at that time.
Okay, so we'll definitely look forward to .live in July. But let's focus a little bit on the journey that MongoDB has been on from a database perspective. Matt, what are some of the really big moments in development of the database? Maybe in the features that have been added, or just big moments in development of the database?
It's a good question. There are three things that really stand out for me, and these are three things that perhaps users of MongoDB, developers, don't get to play with because they're deep down in the core of the database engine. But these three things fundamentally have helped to evolve the technology over the past few years. And so, one is around the storage engine. Number two is around our resilience controls, especially in how we control replica sets and elections. And the third is around controls that would enforce consistency and isolation of your data across a distributed cluster. And that was through adding something called a global logical clock. So starting with the storage engine piece first, when I joined MongoDB in 2013, our storage engine was something called mmap, or memory map storage engine. And it was pretty nice. It was fast. You could update data in place. But it had very coarse-grained write locking. So initially there was a global lock, then it became more granular, it went to a database lock, and then a collection level lock. But it still meant that users who were dealing with write-intensive workloads had to start sharding their database, so start to partition it out across many different nodes much sooner than they otherwise would want to. Now that radically changed in 2015 when we introduced a new storage engine called WiredTiger, and that was based actually on an acquisition we made in late 2014, company of the same name. And what that did out of the box was gave close to a 10x higher performance improvement, especially on those write-intensive workloads, without users having to change their apps. So that fundamentally changed the performance profile, but WiredTiger also changed the efficiency profile of MongoDB because it also offered for the first time compression. By default, it used snappy compression, so you could compress, the amount of data you were storing down on disk, therefore the amount of I/O, the amount of bits and bytes you're reading off of disk, by around 50%, and the amount of data you're pushing out over the network, which is obviously key in a distributed database. So WiredTiger, in one kind of fell swoop, gave us much better performance, better scalability, better efficiency out of the box. And what was really cool about the WiredTiger acquisition was not only did we get this great technology, but we also got the team behind it. The original founders of WiredTiger, Michael Cahill and Keith Bostick, were also the original founders of SleepyCat, around Berkeley DB, who built the Berkeley DB database, one of the world's most widely embedded databases. And so they brought a huge additional bench of database expertise into the company to complement what we already had. And what's really key about the WiredTiger team is that they've all, very often when you see acquisitions happen, the founders and a lot of the early employees leave. Well, in fact, everyone's stayed, and we built on that team. And so, it was a really, really important moment in MongoDB's history to get both that expertise as well as the technology they brought with them. So that's kind of one big foundational change. The second, around about the same time as making WiredTiger our new storage engine, we also adopted a new protocol within our replication and our election mechanism. So, what these things do, these are central to kind of resilience. So if you've got a replica set that's running and the primary fails for whatever reason, or you need to take it down for maintenance, then one of your replicas is automatically promoted in its place. And we were using a custom protocol to begin with, but around 2015, we moved to a raft-based consensus protocol, which actually made elections much faster. So they could complete in just a couple of seconds and much more deterministic. They used much kind of more clever algorithms to figure out which replica should be promoted based on its health, or how frequently the data that it had replicated from the primary had been applied. So you were never promoting a replica that was lagging with old data, for example. So that really improved the resilience and the predictability of the database. And the third major area was around the implementation of a global logical clock, which is based on a pretty hardcore earlier academic concept called Lamport clocks. And what they do is provide a consistent view of time across a distributed cluster. And so that enables us to enforce much stronger consistency and isolation guarantees against the data. So it really brings the guarantees you expect from a single node traditional relational database into a distributed system. So we could do things like causal consistency and snapshot isolation. We could also start to build the foundations for multi-document ACID transactions, especially those across shards. And so it was a major engineering effort, but it significantly improved the consistency, the predictability, the isolation guarantees that MongoDB could give you. And in fact, we wrote a very detailed engineering paper on this, which we presented at the SIGMOD conference a couple of years ago. So for those of your listeners who want to dig more into that, I guess we can provide that in the show notes.
And I'm just listening to the depth of knowledge that you have around these substantial changes, and I'm struck kind of by a couple of things. Number one, your knowledge, but number two, also the challenge in the marketing space. So these are not exactly bells and whistles that you can easily wave a flag about. These are fairly deep level technology components of a database that, tell us about the challenge of marketing these types of things.
Yeah, it's when we say marketing, it's really more about communicating and making it clear exactly what we've done and how it can be used and what the benefits are for our users. And so I mentioned the SIGMOD paper, for example. That's something that it's pretty deep, but it's still highly readable for architects and for developers. And so working with our engineering team to produce that paper, I think is something that can shine much more of a light on this technology, much more than just looking at a presentation or reading a press release, which is what a lot of people think about as marketing. It's really it's not just about telling people, it's showing them, and we can show them through academic papers, we can show them through code, we can show them through performance evaluations. I'm not talking about benchmarks here, because benchmarks typically are highly artificial, and it's a space that we have largely stayed away from. What we try to do is, if a customer wants to assess performance, like assess the performance of our new WiredTiger storage engine when that came out in 2015, take it, run it on your own code, your own apps, your own data in your own environment, with your own people and with your own skills, and we can help you do that. But that will give you a much better way of determining the performance of something than looking at some artificial, YCSB benchmark, for example, which frankly any vendor can game. And so, the challenge really, when we're looking at communicating the value of these things, is to show it. It's not just telling people, it's showing them, and we can show that through the code that we've written, through these papers, through other experiences that people have within the community. So it's really about building the credibility of these things rather than just putting them in a nice press release, for example.
Do you want to talk a little bit about some of the other advancements we've made in the database engine, specifically around transactions? Now, I know this is something that was long awaited. It's something that exists in the relational world, well, essentially because it has to. With the document model, though, it's not something that's essentially required. Do you want to talk a little bit about transactions and maybe why we felt the need to add them to the database?
Sure. Our founder and former CTO used to joke that his engineering team had never spent so much time or money on a feature that so few people would actually use, and that's because you nailed it, Mike. With a document model where you have very rich data structures, you're collapsing what are otherwise separate parent-child tables into a single rich document. You get the same kind of transactional guarantees you get from a relational database. MongoDB has always had single document ACID, or if you like, or single document atomicity. So you get all or nothing and all the isolation guarantees and so forth. And we estimate that covers something like 80% of all application needs. But that said, there are applications that actually do need multi-document transactions. So that was one reason why we built them, because we're focused on making developers' lives as easy as possible, make them as productive as possible. So that was one driver for them. But the other side was that there were some who would completely disqualify MongoDB because they'd been conditioned by 40 years of relational data modeling to assume that any database that didn't offer multi-record transactions was a toy. And by introducing multi-document ACID transactions in MongoDB, and we used a number of the innovations I spoke about a little bit earlier with things like the global logical clock and the WireTiger storage engine as foundations to build those transactional guarantees. All of those objections went away because transactions in MongoDB, they look just like relational transactions, right? They're the same kind of query semantics, the same kind of API semantics. They enforce snapshot isolation, all or nothing execution. And all of that's enforced by the database, right? It's not something you've got to try and play around with in the drivers using some sort of compare and set or find and modify to try and control isolation. MongoDB handles all of those things. And we had a user, a global ISV who works on data integration software, and they were using MongoDB as the database layer for their master data management solution. And they had actually built transactions in code themselves. This was a use case that really did require them. And once they were an early beta tester of our new transactional capability, which we introduced back in 2018. And basically they were able to, by using those rather than their own code implementation, they were able to reduce between 1,000 and 2,000 lines of code from their application, that was non-trivial code, right? That was complex code, hard to write, hard to debug, hard to maintain. All of those things went away. They could push all of that down to the database. But what they also got was significant performance improvements. So they improved throughput by 90%, they cut latency by 60%. And that's because when they were writing these things in code, every operation to the database had to be like a majority committed operation. So it had to, hit a primary and then multiple replicas before it was acknowledged back. We were able to do all of that in a single transaction and leave that majority committed right to the end. So rather than, if you've got a 20 statement transaction, rather than have 20 individual majority write commands, you just have one write command, majority committed write command when you go to commit that transaction. And so this is how they got such strong performance gains. We've had a number of customers who have picked it up. Cisco moved, for example, its back-end e-commerce platform from an older relational database. And this thing is mission critical, right? It's handling close to $50 billion of orders per year. And they've moved that all to MongoDB as a result of transactions. They wouldn't have considered that prior to the availability of this feature. And the one thing I would say is that transactions work across both replica sets and globally distributed sharded clusters. So it's a very, very powerful capability. But again, as I said, at the very outset, and as you alluded to, there aren't that many workloads that actually take advantage of them. But that if you do need them, they're there, and that they work just like the relational transactions and love. But they work at scale, unlike what you would get from a relational database.
All right, so we have kind of the history of what happened in MongoDB up until now. What's coming up next with MongoDB?
So at MongoDB.live in the middle of July, we're going to be talking more about our next major release, which is MongoDB 5.0, which is kind of a big version jump. We're currently on 4.4. We're now going to 5.0. And so you may ask, well, what's so significant? There are a number of things we're going to be talking about a little bit closer to the time, so I don't want to ruin the surprise. But a few things. the reason why we've made such a big version jump, in addition to some kind of big new capabilities that enable us to address, or our developers to address, more workloads with the technology, we're also moving our release cadence. So those of you who have used MongoDB for some time will know that we generally have one large annual release. Going forward, we're going to be dramatically accelerating that. So we're going to be coming out with new releases, in fact, every quarter initially, and then even faster beyond that. So it's a much faster, more rapid release cadence of the core database. And the reason we're doing that is it enables us to get new innovations and features into our community's hands, into our customers' hands at a much, much faster pace than we've been able to in the past. What we would have, some of the things we'll announce in 5.0 were actually done in the time frame for the last release, which was back in July of 2020, but they just missed the release train. So they've kind of been sat proverbially gathering dust in a GitHub repo somewhere, not doing any good to anyone. So by moving to this much more rapid release cadence, we can push new functionality faster out to our users so they can build, better applications faster ultimately. One big part of making that much more rapid release cadence consumable, because we know database upgrades are non-trivial, one thing that we are introducing in 5.0 is something called the versioned API. And so the versioned API is essentially a set of commands and parameters that we make a commitment to that we will not change between releases. And so that what that enables you to do is to really take advantage of those latest MongoDB releases and features without the fear of introducing incompatible changes that are going to require application-side rework. You can really just pin your application to a specific version of the API, and that's going to run unchanged for years, even as you upgrade the database beneath it. And so I guess, what this means is 5.0 is the start of this new cadence of much more rapid releases, and the versioned API gives you compatibility. So you can upgrade the database as freely as you want, taking advantage of new features, taking advantage of new capabilities without having to go back and touch your application. So it really provides you with a level of future-proofing that, again, you just don't get from many other databases out there.
That sounds like a phenomenal change. Just as a developer, I'm super excited by that. And I'm wondering, maybe we're going to get into the weeds here. I'm not sure we have time in this episode. But is that essentially in code a set of pragmas, or how is the developer, how is the API able to consistently access a different version of the database so that we don't have any consistency issues?
The core commands and parameters, the core calls that your application, your clients are making through the drivers and through tools will not change between database versions. And so what we're doing is locking down those most common commands that users use to read and write data to the database, that they use to create indexes or drop indexes, or they use to create collections. Those things will not change between releases going forward. And so that means that you get access to the latest code base. And remember, our drivers are generally forwards and backwards compatibility. So forwards and backwards compatible. So you also get access to latest features without having to change your application. So that's the way we essentially can provide those versioning guarantees. We're going to be providing a lot more information about what this looks like, how you set it in your drivers. During the .live conference, we have actually some talks coming up on it. Jesse Davis is going to give a lightning talk on the version API, how it's designed and how you can consume it. So that's something certainly to look out for .live. But it will be, largely transparent to developers who are writing applications today. They can just get up to 5.0 knowing that they don't have to change their applications for years to come, but they can consume these new releases and get advantage to or get access to new features and new code as they go.
Fantastic. Well, Matt, I want to thank you so much for spending time with us. This has been a great conversation, and I've really enjoyed getting a bit of the evolution and some of the major jumps in MongoDB history. Thanks so much.
It's been a pleasure. I've really enjoyed our conversation. Thanks, guys. Thanks for inviting me.
Thanks for listening. If you enjoyed this episode, please like and subscribe. Have a question or a suggestion for the show? Visit us in the MongoDB community forums at community.mongodb.com.